Hello everyone, welcome back. This is module 4 of Principles of Insurance and Risk Management. In our previous lecture, we covered risk return fundamentals. In this lecture, we are going to learn how to quantify or how to measure risks of a single asset. Now, let's move to this lecture. To find out risks of a single asset, we can use scenario analysis. It is a way to assess or to measure risks using several outcomes. There could be worst, expected, and best situation in an economy, and under these situation we try to find out return of our assets. Now let's look at this example. Assume that you have two assets to invest, asset A and asset B. Both assets require $100,000 initial investment. Now let's look at the annual rate of return under three scenarios, which are worst, expected, and best situation. So if it is in a worst condition, asset A will give you 10% return, and in the same situation, asset B will give you 6% return. In most likely condition, asset A will give you 16% return, and asset B will provide you 14% rate of return. And finally, if everything is favorable, if the condition is at its best, then you will receive 19% from asset A and 20% from asset B. Now let's look at the difference between the rate of return in worst and best condition for asset A. So if you look at the difference, 10% and 19%, that's 9%. So range of asset A is 9%. So range means the difference in rate of return or difference in the value under best and worst condition. Similarly, range of asset B's return is 14%. So based on asset range, asset B is riskier than asset A. So we can say that asset B's return will fluctuate more than asset A if situation changes. Now let's look at another method to find out risks of a single asset. We can use probability analysis to find out risks of a single asset. So probably you know about probability. We covered probability in your statistics course. The concepts are same. So first of all, probability means the possible outcomes of an event. So for example, look at the weather forecast. There is assume that there is 20% chance that it will rain tomorrow. So probability of rain tomorrow is 0.20, and probability of no rain is 0.8 or 80%. So that's probability. And the probability distribution is a kind of model that assigns probability to each possible outcome. And continuous probability distribution, it includes all possible outcomes and their associated probability. Now let's look at the continuous probability distribution of these three assets: most risky asset, asset with average risk, and least risky asset. The most risky assets return will fluctuate from 5% to 33%. Now let's look at the probability distribution of return of asset with average risk. Assets with average risk, the return will fluctuate from 11% to 29%, and the least risky assets return will fluctuate from 17% to 15%. Now we can find out, or we can measure the risks of a single asset using a standard deviation. So it is the most common method. So to find out the standard deviation, we also need to find out expected value of return, which is simply the average rate of return that an investment will generate over a period of time. And a standard deviation indicates the variation from the average or variation from the expected value. So this is the most common statistical indicator of assets risk. Higher the standard deviation of an asset, the more risky the asset is. So here let's look at the how we find out expected rate of return, the formula. So R bar indicates expected rate of return. Here Rj indicates return for the jth outcome, and PR indicates the probability. So if we multiply, if we just do the summation of expected rate of return with and multiply it with the probability, we'll find out expected rate of return of an asset or investment. So here is an example of expected values of return for two assets. Let's assume that the chances of or the probability of pessimistic is 0.25 or 25%, most likely 0.50, and optimistic is 25%. Under these three conditions, that means pessimistic, most likely, and optimistic, asset A will provide you respectively 13%, 15%, and 17% rate of return. So now if let's find out the weighted value in pessimistic. So 0.25 into 13%, that's 0.325%, and for the most likely it is 0.50 into 15%, that's 0.750, and for the optimistic it's 0.25 into 17%, that's 4.25. So overall, if we add this value, the expected return for asset A is 15%. Similarly, if we find out the expected return for asset B, it is also 15%. So based on expected return, both assets are same, because both assets will provide 15% expected rate of return. Now let's look at standard deviation. So in general, as higher standard deviation, the greater the risk. So standard deviation also indicates the variation from the average or variation from the mean. The formula is simply root over of summation return minus expected return squared into probability. Now let's find out the standard deviation for asset A. So we know that there are three outcomes, three possible situations of return: pessimistic, most likely, and optimistic. Under these three conditions, the asset A will provide respectively 13%, 15%, and 17% rate of return. And we have already calculated expected return of asset A, which is 15%. So expected return of asset A is 15% over the period. Now let's calculate R minus R bar, which is 13 minus 15, that's 2%, minus 2%, then 15 minus 15 is 0, then again 2, that's positive. So that's square root of R minus R bar. So minus 2 is square root 4%, 0, and 2 is square root 4%. Then probability 0.25, 0.50, and 50. If we multiply 0.25 with 4%, that's 1%, then it's 0, and finally again that's 1%. So variance of for asset A is 22%. If we square root 2%, we'll find 1.41%. So standard deviation of asset A is 1.41%. Similarly, if we calculate the standard deviation of asset B, we'll find that the standard deviation of asset B is 5.66%. Now let's compare the standard deviation of asset A and asset B. So once again, a standard deviation of asset A is 1.41%, and a standard deviation of asset B is 5.66%. So based on standard deviation, we can say that asset B is riskier than asset A. Finally, coefficient of variation. So it indicates risks in per unit of return. The calculation is coefficient of variation, or simply CB is equal to standard deviation divided by RR. So a higher coefficient of variation indicates that an investment has more volatility relative to its expected return, or simply higher coefficient of variation indicates more risks. So using a standard deviation and expected rate of return for asset A and asset B, we can calculate coefficient of variation for both assets. So based on this, the coefficient of variation for asset A is 0.094 and coefficient of variation for asset B is 0.337. That's the standard deviation of asset A. 1.41% divided by 15% is the expected rate of return, and that's the standard deviation, which is 5.66% for standard deviation of for asset B, and 15% is the expected rate of return. So that's 0.377%. So CB of asset B is more than CB of asset A. So we can conclude that asset B is riskier than asset A, or we can also indirectly we can also say that it is for investment asset A is better than asset B. That's all about this lecture. In our next lecture, we'll cover diversification, risks, and return. So we'll learn how diversification minimizes risks of an asset without sacrificing return.